Hello everyone, I'm Jiaying He. In my project, I will talk about how to distribute the COVID test points evenly so as to test each neighborhood in one of the streets in China. So first of all, let me give you some brief introduction. And in China, when the new cases of COVID-19 emerge in an area, the areas or neighborhoods need to be tested for the COVID-19 test to screen for the disease and isolate from it. So from this measure, we need to solve the problem of uneven distribution of testing sites and the large number of people by using optimization method. And my method is similar to the cutting stock problem that we have studied. So the site I choose is the area of Xixiang Street in Bao'an District, Shenzhen, Guangdong, China. So the optimization tools are very helpful in this scenario, as they can distribute the neighborhoods to the test points and minimize the number of test points to reach the purpose of the testing. So for the background of the project, the input data in this model contains the n original test points, each with specific capacity to receive tests each day. And for these cases, the capacities of each test site are known, which are 200, 400, 600, 800, 1000, 1200, and 1400. So the number of 17 neighborhoods of each places is known, and we need to distribute the testing point correctly so that we can meet the need of each neighborhood to receive the COVID test. The sets and parameters of this project are listed as follows. N represents the neighborhoods that are going to be tested, indexed by J with N total. T represents the sample being tested points, indexed by I with M in total. C represents the capacity in each test point, indexed by C. And for the parameter definition, Wij means the amount of test points assigned to each neighborhood. And Ci is the test points capacity with the amount of those capacity, and Ti is the test point defined as T1, T2, T3, etc. And Nj is the amount of people in each neighborhood defined as N1, N2, etc. And Zj is the total amount of neighborhoods being tested by the test points. So the decision variables include whether or not a neighborhood is being tested by certain test points each day, and it's a binary variable. We can written as Xij equals to 1 if test points j tested in neighborhoods I, and 0 otherwise. So finally, our objective function is to minimize the test points that satisfy each neighborhood that need of being tested. For this project, we have 4 constraints. The first one is the overall neighborhoods are tested by the test point with each capacity written as Ci multiplied by Ti greater than or equal to Zj multiplied Xij. The second is each neighborhood is tested by number of test points. We can written as Nj less than or equal to Ti multiplied by Ci. And the third one is test points have the capacity of several range. And the fourth one is taking test variables must be the binary. So for this project, we selected Python as our project solver, and we conclude that after the calculation, we can set total of 23 test points, 2 sets of capacity of 400 test points, and 4 sets of capacity of 600, 2 sets of capacity of 800, 3 sets of capacity of 1000, and 2 sets of 1200, and 10 sets of capacity of 1400. So for this study, the COVID test points in Xixiang Street have been optimized, and 7 neighborhoods can be arranged for detection through the presentation of the results. Through the initial definition of parameter to the list of constraints, to the definition of variable, and finally to the calculation of the arrangement information of each detection point by using Python algorithm. So the optimization really helped us in many aspects of our lives, and through the study of this case, we can apply it to any region of China to help the government medical level for further observation and research. Thank you.